Okay, so for section 13.2, we're looking at what we refer to as circular functions. And what this really is about is thinking through what we call the unit circle and how this applies to our sine, cosine, tangent, secant, cosecant, cotangent functions. And so the unit circle, if you remember, is going to be a circle where you have a radius of 1. And so that means that these points are easy to identify, and because they are all 1 unit away from the origin on the axes. And so they just have 1, 0, 0, 1, negative 1, 0, 0, negative 1. And when we use the unit circle like that, then we know that any point that is on here, and so if this is x and y, then when we draw in a right triangle so that we can now start thinking in terms of trigonometry, we know that this is x, and this is y, and this is 1. And so instead of having the sine, if you remember before, being y over r, where r is your hypotenuse, and also the radius of the distance or radius from the origin to that point, we let it all be 1 unit away, which then simplifies things, because when we start looking at the 6 trigonometric function, we know that the sine of, and if we call this theta here, theta equals y over 1, or just y. And then the cosine of theta equals x over 1, or just x. And so now we have made this much simpler in that we can say the sine of the angle is equal to y. The cosine of the angle is just equal to x. And then the tangent of the angle, well, if you remember, we talked about how tangent is the same as sine over cosine, which is just going to be y over x. And so we get y over x, y as the value of tangent. And then the same thing's true for when we go through and do our other 3. We have the cosecant of the angle. Well, it's just going to be 1 over y. The secant of the angle, remember, is just the reciprocal of cosine, so 1 over x. And then the cotangent of the angle is just going to be x over y. And so now, in thinking in terms of the unit circle, that really does make our life pretty easy to go through and do these. We're going to look at these in terms of radians. So now, instead of theta being an angle in terms of degrees, it's going to be an angle in terms of radians. And so now we need to go back through and remember how to connect up the different values with the reference angle. And so the 3 reference angles that we're going to worry about, or actually the 4 reference angles, would be, so let's draw a new picture here. And so the first one is going to be 0. And so that one, we're going to have, our coordinate was 1, 0. And so that's going to be really easy. The sine of 0 is going to equal 1, 0. The cosine of 0 is going to equal 1. The tangent of 0 is going to equal 0 over 1, or 0. And so you can go through and calculate all those. And then the 90 degrees, or if you remember, the circumference of our unit circle is 2 pi. And so in radians, 90 degrees is going to be pi over 2. And so remember, this right here is going to be pi over 2. And so that's going to give us where we have 0, 1. And so you can go through and calculate all those using 0 and 1 as your x and y. And then in between, we're going to look at 3 angles. We're going to first look at the 30-degree angle. The 30-degree angle is going to happen at pi over 6. Remember, the way that we converted was we said we could multiply the angle times pi over 180, right? Or you could do 30 over 360 times 2 pi, which works out to be the same as 30 times pi over 180. And so in radians, that angle is pi over 6. Well, that's a 30-degree angle, and so if this is 1, that's the long side of a 30, 60, 90 triangle. And so the hypotenuse is going to be double the length of the short side, which is 1/2. So the y value is 1/2. And then the long leg, this leg right here, is going to be 1/2 times √3. So pi over 6, your coordinates are √3 over 2 and 1/2. So the sine of pi over 6 equals 1/2. The cosine of pi over 6 equals √3 over 2. And if you know those two, then you can just go through and calculate the rest of them very quickly. The next one is for when you have a 45-degree angle. 45 times pi over 180 is pi over 4, and so this is pi over 4. And if you remember, the relationship between the hypotenuse, which is 1, remember, because this is a unit circle, so our hypotenuse is always 1, and the two legs is √2, and so you just divide by √2, and so 1 over √2 just turns out to be square root of 2 over 2. And so the x and the y for pi over 4 is just √2 over 2. And then for the 60-degree angle, which turns out to be pi over 3, you go through and do the same thing we did here, except it's just in reverse. The short leg is 1/2, and so the x value for pi over 3 is 1/2. The long is √3 over 2. And if you can reproduce these 5 points for the angles of 0, pi over 6, pi over 4, pi over 3, and pi over 2, then you can recreate them all the way around the circle using the different reference angles. The way that I remember it is the 45s always are the same, √2 over 2 and √2 over 2. If it's in the second quadrant, then the x value is negative √2 over 2, and positive √2 over 2, just getting your signs correct, right, in that second quadrant with a reference angle of pi over 4. If it's a reference angle of 30 degrees, I just remember, well, I know that one of the two coordinates is 1/2 and the other is √3 over 2. And so if it's a 30-degree angle, well, when you draw in a 30-degree angle, it's obvious which one is smaller, right? The y value is smaller. And so down here, if I have a reference angle of 30 degrees down there, that would be, well, the y value is a smaller one, and so the y coordinate's the negative 1/2, and then the x coordinate's the larger one, and so the x coordinate's the √3 over 2, and then I just get the signs right because it's the third quadrant, so x and y are both negative. Okay, and then you just have to go through and convert all that to radians like we did in the last section. So just as a couple examples, if I have a problem where I want to find out what are all the trig functions for something like, let's say, 11 pi over 6. So the first thing I have to do is recognize, okay, where is 11 pi over 6? Well, when I think about it on my unit circle, pi over 6 is 30 degrees. And so if pi over 6 is 30 degrees and I've got 11 of them, that means I've got a 330-degree angle, or 330 out of 360 all the way around. And so that is an angle that looks like this all the way around till I get to here, right? And so what is this coordinate going to be? Well, this reference angle is 30, or pi over 6. And so this is going to be, the y value is the smaller one, so 1/2, √3 over 2. The y is negative because we're in the fourth quadrant. And so using my table up here, the sine of 11 pi over 6 is just equal to the y value, which is negative 1/2. The cosine of 11 pi over 6 is just going to equal √3 over 2. The tangent of 11 pi over 6, well, it just equals negative 1/2 over √3 over 2, right? The y over x value. And so negative 1/2 over √3 over 2, well, the 2's cancel. So that's negative 1 over √3, which is the same as negative √3 over 3. And then I just do my reciprocal functions. Cosecant of 11 pi over 6 is just going to equal negative 2. The secant of 11 pi over 6 is going to equal 2 over root 3, which turns out to be 2 root 3 over 3. And then the cotangent of 11 pi over 6 is just the reciprocal of this, which is root 3 over 2 over negative 1/2. And so the 2's cancel, and so I get negative root 3. And so those are the values of the 6 trig functions at that point. And so if you can just get the point labeled, then it's really easy to go fill out the value of the 6 trig functions. The other problem I want you to be able to do is if you're given a point on the unit circle. So for example, if you have something like this where you have the point is going to be, let's say, something like 1/6 and root 35 over, and let's say negative 1/6 and root 35 over 6. Okay, this turns out to be on the unit circle because when you square 1/6, you get 1 over 36. When you square root 35 over 6, you get 35 over 36. Those add together to give you 1 over 1. And so x squared plus y squared does equal 1 in that case. And so if you want to find out what the functions of the rest of these are, all you have to think about is the sine. And so this is going to be at some angle. And so if you were to graph this, it would look like this, right? It would be something like this. Negative 1/6 root 35 over 36 over 6. And so this angle right here, we'll call it r. And so the sine of r is just equal to y, root 35 over 6. The cosine of r is just equal to x. The tangent of r just equals root 35 over 6 all over negative 1/6. The 6's cancel, and so you get negative root 35. And then the cosecant of r is just the reciprocal of that, which would be 6 over root 35, which is just the same as 6 root 35 over 35 when I simplify. The secant of r is just going to give you the reciprocal of 1/6, which is, or negative 1/6, which is negative 6. And then the cotangent of r is just going to be the reciprocal of this, which is negative 1 over root 35, which is the same as negative root 35 over 35 when I simplify.